So I don't know. Do you want to move the negative exponents first, or do you want to just subtract them? I'd say, how about on this problem, we'll move all our negative exponents first, and then on E, we'll kind of just leave them where they are and do our subtraction. So if I was to rewrite the problem on D, the m to the negative first would go to the denominator, become m to the first. The n squared can stay up there. M to the third can stay down where it was, and the n can stay where it was, and that's n to the first. So, are there more n's in the numerator or the denominator? There's more up top. We have 2 up here, 1 down here, so if we did 2 minus 1, we get 1 more n in the numerator. As far as the denominator, we have m to the first times m to the third. So our old property, when you multiply the bases, you add the exponents. So that would be m to the fourth. Double check. Anything with a 0 power, any negative exponents. Great, we're good. All right, so this one we'll try subtracting them. So for the x's, we have 2 up top. We have 1 in the denominator. So we're going to be doing 2 minus 1 up top. Now the y's, we have negative 1 up top. We have 4 in the denominator. So there are more in the denominator. So we're going to be doing 4 minus negative 1. That's the tough part, because we know we're going to be doing plus 1, right? And 4 plus 1 is 5. So think of like a number line. Negative or positive 4 is actually 5 larger than negative 1, because it would have to go to 0 and then negative 1. And then z's. You have 4 up top, negative 3 in the bottom. So there are more up top, and we're doing 4 minus negative 3, which again means plus. So let's clean up our final stuff here. For x, 2 minus 1 would give us x to the first. For the z, 4 minus negative 3 becomes 4 plus 3, which is 7. The denominator, we have 4 minus negative 1 becomes plus 1, which is 5. So it gets tough kind of remembering all the different rules that we have for the different exponents. Oh dear. All right, scientific notation. Just trying to scooch myself up here. There we go. In 2000, the total amount of paper and paperboard recycled in the United States was 37 million tons. I bet we're going to need that number. The population of the United States was 281.4 million. We'll probably need that as well. On average, how much paper and paperboard did each person recycle? So, when you're doing average, you do the total amount divided by the number of people, right? Like if we were going to eat 8 slices of pizza and there were 4 people, you would do 8 divided by 4, giving you 2 slices per person. So we're going to be doing 37 million divided by 281.4 million. But we're going to set it up with scientific notation. So 37 million tons would look like this. 281.4 million people, 281.4 million would look like this. Now the problem wanted us to do this in scientific notation, but honestly we'll do it on the other 3 down there. Let's just divide these kind of as they are, and then we'll write our answer in scientific notation. I gotta get my calculator, because I don't know my multiples of 281.4 million. 37 million divided by 281,400,000. All right, I'm running out of time. So it comes out to 0.131. We'll finish up the rest in the next video.